Welcome to another PlebDevs tutorial where today we're going to be talking about creating reproducible dev environments using Nix. So with Nix, we're going to be able to just run this one command, nix develop, and create the same development environment that anyone else can create for specific projects. And I say this is not for the faint of heart because Nix is not the easiest thing to learn, but it's definitely very valuable. So what is Nix? Nix is a package manager, it is a language, and is an operating system. So you can see here we have Nix OS, which is a Linux distribution, and it uses Nix, the package manager. The Nix package manager is using Nix packages. There's also Nix Darwin, which is an implementation for Mac OS. There's Home Manager, which is something that we will not need to cover at all. And you can see there's just all this interconnecting web. Nix is not a very simple thing, but we're mostly going to just be focusing on the package manager for creating our reproducible development environments. So what is package management? Package management just helps you automate the installation, upgrading, and configuring of software. So some examples are apt install package. Apt is the package manager that you'll see on Ubuntu, or if you're on Mac OS, you might use brew install package name, or different runtimes have their own package managers. So Node has npm and Python has pip. It's usually all the same syntax. You say whatever the package manager is and then install. And ideally with package managers, you should just run one command and you should have that software on your computer and it should be working. That's not always the case. And there's a lot of limitations of conventional package managers. So something is dependency conflicts, also known as dependency hell. So say we have this example over here where we're building this app, and this app relies on two libraries, foo client and bar client. However, each of these is fine, but they each use their different versions of this requests library. And that can cause problems because now you're trying to manage these two different versions, and it will ultimately result in your app not working. When you make changes, install new packages, it can be hard to roll them back, and it can cause system-wide changes. So whenever you run sudo on Linux, you are giving permission for that app to, or that package manager, whatever command you're running, to have root access and can change things on the system level. So the question you kind of got to think about with conventional package managers is, how do you get all these specific packages for each piece of software that you want to run? Maybe they're different versions, they all have the same name. It's not the easiest thing to manage. So this is why we like Nix. Nix is reproducible, it's declarative, and it's reliable. And the idea of being reproducible is that if I create a package and it works on my machine, it should ideally work everywhere. And that's not the case for other package managers where you have apt that works on Ubuntu, and now you can't really install those packages using apt. If you're on Mac, you have to use brew and they'll be different, and there's just all these annoyances there. It's declarative. Nix is declarative, so you write in your Nix configurations exactly what you want your project to look like, so there's no confusion, and this makes it trivial to share development and build environments. Nix is also reliable. When you install new packages, it's not going to break other packages. You can always roll back to previous versions, and each package, even if it has the same name but different versions, will be stored in its own place. So because we are interested in the package management side of Nix, we want to know where we can find these packages. So if you go to search.nixos.org, this is probably where you'll be looking for your packages. So here we can just search something like C Lightning, and boom, there it is. And then it doesn't give you much documentation here, but you can see there's kind of some different options. There's Nix shell, Nix OS configuration. So this is if you're running Nix OS, Nix env. So let's try this Nix shell command out. So I already have Nix installed, which we're going to go through in a second, but I just want to show you this real quick. this is really cool. I can run this package without actually installing it. So I say nix shell-p c lightning, and it's going to try to find it. Internet is slow here, I think, so we'll see if this works. I'll let that run for a minute. Going back to the slideshow. So on that Nix packages website, you may have noticed there's unstable. Go back there. We have here this latest release and unstable, so I can change these. And this is just saying like which version of these packages do we want to pull in? Do we want to pull them in from kind of the most recent working channel, or the unstable channel, which may have newer versions of your packages but not guaranteed to be bug free? And again, unstable is the latest, but it may change. And stable is ideally has long-standing support, and when you set the version of the Nix channel that you are pulling packages from, it'll always stay the same. But if you set it to unstable, then as the unstable branch moves forward, then those packages will also move forward. This search website is pulling packages from this GitHub repo. So this is the biggest repo known to man, and in here we'll start to see like we have packages, and there's just a ton of packages in here. So these are all getting pulled in to this website for searching. And anything can be a Nix package. You can build a Nix package, I can build a Nix package, and it can just be on my GitHub. It doesn't actually have to be on this nixos.org website. Just something to keep in mind. And another argument for why you should use Nix, this chart is showing here all of the different package managers, and on the left we have the number of fresh packages and the number of packages on the x-axis. So we can see here we have like Ubuntu down here, we have Raspbian, that's what Raspberry Pis run on. PyPy is the Python package manager, and then all the way up here we have Nix packages stable. It's way ahead of everything else. And then even farther we have Nix packages unstable. So on this you can see that there's just way more packages on Nix than there are on any other package managers. So why would you not want to learn Nix? Well, it's hard to learn. I still don't really know what I'm doing. I'm just kind of trying to piece together little things that I find out there and trying over and over, and eventually it works and does what I want. The nice thing is that once it does work, it will always work. Another thing is we're going to be talking about flakes, and I'll show you that in a minute, but a lot of people say flakes are the future, this is what we should be using, but they're pretty much undocumented. You'll notice if we go back to here, we have instructions for Nix env, Nix OS configuration, Nix shell, but nothing for Nix flakes. But that's okay, because we want to learn how to use Nix flakes. So you may end up looking like this guy and getting frustrated trying to get your software to run. So as a PlebDev, why would you want to use Nix? Well, we can create reproducible workshop environments. So I'm creating this tutorial in preparation for some workshops coming up where I'll give you a Nix environment and you won't have to worry about downloading Bitcoin Core, downloading Core Lightning, and doing all this boring stuff just to start writing your code. Should work on any operating system, so again, I can build my development environment and give it to you and you'll have the same environment. There's not going to be any dependency conflicts. All you have to do to spin everything up is just execute nix develop, and you'll get, for example, the Bitcoin and Lightning nodes and any other packages that you need. Another thing we use here a lot at PlebDevs, Replit, and Replit is using Nix under the hood. So if we go to this Replit documentation here, you can see there's a replit.nix, and all you have to do, your replit.nix will look something like this. You just have to add in here the package names, and you can find these packages again on search.nixos.org. So this is just a fun little thing that under the hood, Replit is actually using Nix to create its development environments. And finally, Nix is the future, I believe, of reproducible builds on Bitcoin. With Nix, we'll be able to easily deploy software and make it so that people can run it. All right, so now let's get into actually building a flake. What we're gonna need to do is install Nix with flake support. So again, remember I said it's not very well documented, and that's partially because it's still considered an experimental feature. If you go to the wiki on flakes, you'll see that it says to enable flakes, you're gonna need to add this experimental features. So you can run Nix commands with this flag if you want to enable them temporarily. But we just want to use them overall, so what we're gonna need is this experimental features equals Nix command and flakes. But the way that I recommend you install Nix is from this determinant systems installer. So all you have to do is copy this script into your terminal. I already have Nix installed, so I'm not going to do that, but what you could do is just copy that and just get out of this. Copy that, run it. It'll ask you some questions. You can just go with the defaults and Nix will install. So with this, it's a more flexible installer, it's easy to uninstall, and it enables these experimental features by default. So if you use the determinant Nix installer, then you won't have to worry about this stuff here with enabling flakes. All right, so ideally now we have Nix installed. So let's look at what it looks like to start using Nix and building a flake. So let's open up a terminal here. And we want to make sure that we successfully installed Nix. So if we just say Nix -- version, we can see I have version 2.205. And if you need help with any commands, just run Nix help. And we're actually going to go through something in here. So you can read through this. Here's all the commands that you can use with Nix. Nix develop is what we're going to use. And if we go down here, here's an example of creating a new flake. So we will do this. We will say mkdir to create a new directory, and we'll call it hello Nix. cd into, oh, actually, I think this will create the directory for us. So this, let's try this. Let's say Nix flake new hello Nix. All right, so we can see here it wrote out a flake.nix to this directory. So it does create the directory for us. And now if we list, the only thing in here is a flake.nix. Let's look at that. It's very simple. We will see that's what we also have here. If we want to use this package, all we have to do is say, if we want to use this flake, all we have to do is say Nix develop, and it's going to install a bunch of things, and then you'll have this, you can see that it's, what it's doing here is, it is taking a package from Nix packages.legacy packages, and it created this system here. This is the system that I'm running on, but when you run new flake, then you'll get a different system depending on what system you're running on. And so it's pulling from packages for this system, and it's pulling a package called hello. Actually haven't looked, but let's see what happens if we search this Nix packages for hello. We can see that we have this package here. So that's what we're pulling in, is a program that produces a familiar, friendly greeting. All right, let's see. This is done. So there was some more stuff up here. there's all of this stuff, this unpack phase. So now that we're in the Nix shell, you can see my terminal has changed to show that I'm in the Nix shell. And then I can run unpack phase. And there's a bunch more in the docs here. We have that we could, now that we unpacked it, we can cd into hello. And this is for building new packages. So I'm not going to spend much time on here. We're building this hello package, but what we're most interested as PlebDevs is using Nix as a development environment. So we'll get into building a development environment in a minute, but if we just go here, then again, just following these docs, you can follow more. Then we have the configure phase. It'll go through and configure. And this is all stuff that you wouldn't have been able to run unless you ran the nix develop command. So let's look at more in depth into this flake. It has three main pieces. It has the description, inputs, and outputs. The description is just whatever you want to say. It's just to describe how people should use this flake, what it is. We have inputs that specify our dependencies. And in this case, our only dependency is Nix packages, and we're setting the URL property to the unstable branch of the Nix packages repo. And then finally, we have the outputs. So this flake is taking in dependencies and then it's outputting something. In this case, it's outputting this hello package. So we can see here that outputs takes these two parameters. It takes self and Nix packages. And Nix packages comes from what we defined here in the inputs, and self is just referring to this flake itself. And then what we're doing is we're saying that the packages.x86 64 linux.hello, this is basically creating a new variable. It's going to be equal to the hello package that we saw on nixos.org. And then what we're doing here is we're saying that the default package of this flake is going to be equal to self.packages.hello, and that's what we defined up here. All right, so moving on, we're going to get into what we're really excited about here is making development shells. So we have this, comes along with packages, is the make shell, MK shell. You can read more about it here, but basically it creates a development environment for us. If you want to get more into exactly what we're doing here and how the syntax is, I still struggle a lot with the syntax. This is a programming language, but it's very functional and it, to me, is not intuitive to read. But I recommend going through the Nix pills, and that will give you a good understanding of, like, here we have the basics of the language, and here you'll just kind of get to go through some exercises of learning the Nix language, because we need the Nix language in order to build these flakes. So what we're doing here, I will just copy this into a terminal and go through it. I'm gonna mkdir dev flake, spelled mkdir wrong. Go in there, and we will just open this up in our code editor. And I'm gonna create a new file called flake.nix. So this is what that flake new command did. We can do it manually as well. So we have this flake in here, and I've just pulled out this variable of system equal to x86 64 linux. So if when you ran flake new, if it gave you a different system, then you'll probably want to change this. Right now, this probably would only work on this x86 system, but we're going to go through in a minute how to make these flakes work everywhere. But just for simplicity's sake for now, we're just setting the system to one static system. So I've just kind of pulled this apart into two pieces. Notice I'm using this let command, or this let method here. So we're saying outputs is equal to this, and what let is saying is, like, basically these are all going to be a bunch of variables that we use in this block. So we're letting system equal x86, and we're letting packages equal the packages for our specific system. And then these variables are going to be used in this block. So now we're saying that we have dev shells. You could have multiple dev shells, and dev shells for our system and the default is going to be equal to packages.makeShell, which comes from the Nix packages. This is basically, you can think of this as a function, and these are the values that we are passing to it. This shell is going to be named default dev shell, and right now it's not going to have any packages. And finally, it's going to execute this shell hook. So this is just bash that will be executed once the development environment gets up. So right now there's nothing really exciting happening in here, but if we run Nix develop, see it's going to install Nix packages, and then it outputs I'm alive. So that's what echo does. So we can make multiple dev shells if we want to, depending on our development setup. So all we have to do is copy this, and it's just this last piece here. So what we changed was, instead of saying devshells.system.default is equal to packages.makeShell, what we're doing here is we're saying it's equal, the dev shells for this system are equal to this big object here, which is going to have multiple dev shells in it. So we're saying that the default is equal to packages.makeShell, and with Python is equal to packages.makeShell. So we're just kind of taking this and nesting these within this devshells.system. And you can see here, all we've done is we've added Python 3 to the packages. And this with value, this with operator here, is saying everything within this variable is going to have the context of packages. So we could say this without with packages, and then we would have to say packages.python3, but this just makes it a little bit simpler to write, even though it's confusing syntax. And again, this is just the same, but in this one, the shell hook is going to echo our Python path. So let's see if I have Python right now. Which Python? Nothing. So let's try Nix develop, and then we'll do dot hashtag and then the name of our shell, because if you have a default shell, that will run if you don't provide any arguments, but if you don't, then you'll have to set the name of the shell that you want to run. So we say Nix develop and then the shell name, and this is where Nix starts to get frustrating, is trying to debug these errors. So we got an unexpected end of file. So these often expect a semicolon there, so I'm just going to collapse these so we can see it a little bit better. So it looks like our dev shells are wrapped correctly, but then see we have in, and then we have this curly brace here and this curly brace here, but the opening one for the flake is missing. So we just need to add that, and let's see if it wants a semicolon. No semicolon. Let's see, let me just take this. I'm going to delete this whole in. Replace that. So I think I was maybe even missing one more curly brace. But you'll just have to make sure that everything that you do is closed. Let's see, let's hope this works again. Alright, so this time I forgot to run the dev shell name, so this just ran the default one. But if we run our one that we want, now it's going to install Python, and then it outputs I'm alive, and this is my Python path. So now when I say which Python, we get this because it gets loaded into our path when we run this flake. And I can type exit. Also, you'll notice here that this one is named Python dev shell, whereas this one was named default dev shell. But if I exit and try to check my Python again, we don't have it because we are outside of our development shell. All right, so this hopefully will be exciting for you. We are gonna make a flake with Bitcoin Core in it. So we will have pretty much the same setup, and we're gonna have a shell hook that is quite long, but we are just defining a new dev shell here. I'm just gonna replace what we have. This is in 2 sections, so you'll have to take this as well. And let's just make sure this runs. All right, it looks like it's a valid flake. So let's go through it. We have the same things here. We changed the description to a flake for regtesting Bitcoin Core. Again, we have the same Nix packages reference. We could set this to a version if we wanted to, but we're reckless out here. And then what we're doing is we're creating this new default shell, calling it Bitcoin Dev shell, and it takes 1 package, Bitcoin D. So again, because this can be kind of confusing sometimes, we can search for Bitcoin D, and we'll see that it is in fact a package. If we go to the unstable, it is in fact a package on Bitcoin, or on Nix unstable. So that's how we know we'll be able to get it there. And so all we're doing is we're installing Bitcoin D, and then we're executing this shell hook. So the shell hook is going to do a few things. This is all bash, which we'll probably end up doing a tutorial on here soon. But just to show you what this is doing specifically, we're creating a new variable called path to Bitcoin, and we're exporting it to the broader shell environment. And we're setting that path to Bitcoin equal to our working directory. So you can see if I go in here and type pwd, it will print my current working directory. So, or maybe I just need to do pwd, yeah. So pwd prints the current working directory that I'm in, and then we're setting it to have this other directory called .bitcoin. And then what we're doing here is making that .bitcoin directory as the path here. So -p will either make it, or if it already exists, it won't throw an error. Here we are creating our bitcoin.conf. So we're just setting regtest equal to 1 and daemon equal to 1. So if you're familiar with the Bitcoin D CLI, then normally what you could do is say -regtest -daemon, and you could start it up with these same settings this way. But in this case, we are creating a bitcoin.conf, so we don't have to pass those flags each time. And then just to make things simple, we are creating these aliases. So we're creating a btcd regtest and a btcli alias. And these are going to point the data directory to our path to Bitcoin. And finally here we have a function called reset that will try to stop Bitcoin. It will remove the path to Bitcoin, and it'll create a new one. So this will clear your chain state and get you in a fresh development environment. So right now I'm out of the flake, and because I already ran it, we have this .bitcoin, but it's empty. So let's see what happens if I run nix develop. It's going to evaluate the flake and execute this shell hook. So now we should see in .bitcoin, we have this bitcoin.conf, which has our regtest and our daemon settings. And now we have these aliases. So right now, we want to start up Bitcoin D. So we'll do that with this alias here, with btcd regtest. And we can see Bitcoin Core is starting. So now we have access to the BTCLI. And bam, we just executed a Bitcoin CLI command, and it got built from the Nix packages, but we didn't have to deal with compiling it from source or anything like that. And so now we can start doing fun things with Bitcoin CLI, like we can, let's see, I think it's new address. Let's see, BT. So this is how you figure out how to use it. You say BT CLI help, and then we want to grep. This is searching for a certain word. Grep for adder. So let's see what we've got here. Get new address, that's what it was. So BT CLI, get new address. Now this is an error that's saying our wallet is not loaded. So we will just say BT CLI create wallet and default. And now we should be able to get a new address. And then we're gonna make ourselves rich with generate to address 101 blocks, and there. And now we should have a bunch of regtest coins all mined in these blocks. So that's cool. With just this flake here, we instantly have access to Bitcoin CLI, and the chain state that we create will only exist within this local environment. So if you're running Bitcoin Core normally on your computer, you might have a, let's see, I probably have it in your home directory. So if we say ls and then in bash, this squiggly line is your home directory. And see, I have .bitcoin here as well, but the instance that I'm running within this flake is not touching any data that I have there. So helps keep things clean, and you can always just delete the directory within this development environment, but not worry about your other chains that you spent hours and hours syncing. So that's cool. Now we can develop with Bitcoin Core. I mentioned earlier that Nix makes it possible to run the same flake on any system. The current setup that we had does not allow us to do that, but here we're going to make some changes, and then you should be able to take this flake that I'm creating here on my Linux machine and make it run anywhere on your machine. Let me just copy these in here. So what's different about this one? We added a new input. We added flake utils. And remember I said that packages don't necessarily have to come from Nix packages. So here we're pulling it from this guy Numtide's repo, and he has a repo called flake utils. And we're pulling in flake utils from there. And here we're doing something a little bit different that starts to look really confusing. So we added flake utils as an argument to our outputs. So now everything within here will have access to flake utils. And what we're doing here is we're calling this function that exists in flake utils. It's under lib at each default system. So this is going to pretty much loop through each default system. And as it's looping, that system that it hits is going to be assigned to this variable. And then again, we see let here. So we're letting packages equal nix packages.legacy packages.system. So this looks the same, but this system variable is going to be set dynamically through this function here. And so now packages will be in here, and then we do exactly the same thing. So all that's different is we've wrapped our pre-existing shell with this each default system so that it will work anywhere. So a little bit more to get you excited about Nix. There's a project called Nix Bitcoin that will help you install fully featured Bitcoin nodes with an emphasis on security. So here's the whole project. They have a GitHub repo that has a bunch of stuff. So this could be useful for messing around. They have examples, and let's see if they have a flakes, and they have a flake.nix. So this is going to be a really complicated flake, but places like this are helpful for referring to so that you can start to see how other people are doing these things. And what this will do is pretty much create a fully featured Nix Bitcoin node. And just briefly, let's explore this for a minute. It has modules. So these are taking in nixbitcoin.nixos modules.default. So let me just go look at that. Modules. And there should be a default in here. Let's see, this was NixOS modules. Maybe we clicked on the wrong one. Well, anyways, it's pulling in stuff from this modules. I'm not sure exactly what the default value is, but that's something that you can mess around with. Maybe it's this modules. Anyways, see, this is just showing my limited knowledge of Nix, but it's definitely powerful and something that I'm going to continue learning about. Nix Bitcoin offers all of these. It offers Bitcoin D, C Lightning, CL Boss as a C Lightning plugin. See what else. You can get Join Market. You can get hardware wallet integration. All kinds of good stuff on Nix Bitcoin. And to finish it off, here's a list of resources. You should start reading through these. These are all flake focused. So I mentioned that flakes are still experimental features. So there's a lot of good blogs and all that on flakes, but you probably won't find much of it on the official Nix documentation. Flakes have been around for the last 5 years or so, but they're just slowly becoming the standard. So that's all. I hope that I inspired you to want to start learning Nix, and in future workshops, I'm going to be using Nix more. Ideally, you won't have to write any Nix, but it will just help me set you up with a development environment that you can use over and over and over again, and it should just work on your system if everything goes well.